worth of lecture. Everybody take 5 minutes. We'll come back at 5:24, 5:25 about that, and I will start taking your questions on absolutely anything that we have covered so far.
Yeah, are you there, Morgan?
I'm here.
Yeah, sorry about that. I didn't unmute myself.
Okay.
Yes, it was in the last bit, and we've got in brackets a minus 1
All squared. Yep.
And then you get a squared minus 2a. Where do you get the a from there?
Okay, so I'm just going to do the a minus 1 squared part, okay?
Yeah.
Just taking this part, remembering what that's actually asking for is a minus 1 times a minus 1.
All right.
So when we do that, a times a
is
a squared. A times negative 1 is negative 1a. Negative 1 times a is negative 1a. Negative 1 times negative 1 is positive 1. Now when I put together those two pieces, that's where my negative 2a comes from.
Okay, right. Okay. Thank you, yes.
No problem at all.
No, why is it negative and not plus 2a?
A minus 1 times a minus 1. Negative 1 times a. What's negative 1 times a? Negative 1a.
1a.
Negative, and then we do it again. Negative 1 times a is also negative 1a. So if you owe 1a and then you owe another 1a, in the end you're going to owe 2 a's.
Oh, they don't become a plus then?
No,
negatives.
Because they're not multiplying. They're actually just subtracting.
Yeah, right. Thank you.
No problem.
Mm-hmm.
Okay, let me catch up on these requests really quickly. So we're being asked for, from the polynomials, yes, Caitlin, go ahead. What about the functions and triangles examples?
Hi, I just was having trouble figuring out how to write it.
Okay.
Just when you were doing that, I just don't really understand where the relationship between like the area and the height and the area and the hypotenuse, like why you're picking those specific relationships, like the A to H.
Okay.
Does that make sense? I just don't really know where you're getting those relations from.
Okay, so when we've got a triangle like that, and of course we're being asked for the area, and we know that the area of a triangle is 1/2 base times height. And in this case, we happen to know what our base is. It happens to be 4. So if we were asked for the formula of the area of this just in relationship to h, we would know that because I can go 2 times 4, sorry, not 2 times 4, 1/2 times 4 times h, it just brings us down to 2h. Now I've got a formula for the area that no matter what h ends up being, so if I changed the height on this triangle or shrunk the height on this triangle in any sort of way, the formula would still hold. So far, so good? Kind of. Okay. All of this is just telling us I can, because my base isn't changing, but my height might change, I now have a relationship for what that's going to be. Then I went through this process of trying to figure out what is the relationship between h and c. Well, we know that relationship from the Pythagorean theorem because we know that our hypotenuse is equal to a squared plus b squared, where we can replace a and b with h and 4. So that c on its own ends up being h squared plus 16. So if we were then being asked, well, what is the length of the hypotenuse in relationship to h, we could state that as a function like that. We could also go the other way. I could talk about h in relationship to c. So in every case, what I'm doing here is I'm saying, okay, I can make, if I'm trying to figure out this, all I actually need is this piece, right? I don't need to figure out my hypotenuse. I just need to know what my height is. Now, if we carry on and then I reverse these things, and when we reverse them, we found out that we could find that h would be equal to square root of c squared minus 16. And I then had somebody come along and they said, okay, well, that's lovely. So then if you can figure out the height with relationship to h, what if I'm not in control of h? What if I'm only in control of the length of the hypotenuse and I can change it? What does that do to my area? Okay, well, now I can say, well, I know what h is in relationship to c, which means that I can change the area of this triangle, or I can calculate the area of this triangle by replacing h with this, so I'll know that it's going to be c squared minus 16, so twice the square root of c squared minus 16, and that will give me, I need just a little bit more space here, sorry. The area in relationship to the hypotenuse then ends up being twice c squared minus 16 square root of, because I can replace h with that phrase, with that expression. So now, if I was only in control of the hypotenuse, in terms of calculating the area of this triangle, I would have a formula for it. So when you're going through all of these things and you're trying to figure out the relationship between different variables, it's largely about, if I only had control of one variable, how would I determine what this formula looked like? Sorry about that, Allison.
Can I just, so is it about,
Yes.
you want to know the relationship, or h, what is h in relationship to c, if you're looking at changing the shape of the triangle?
If we're going to change the size of the triangle.
Or the size, sorry, yeah.
Yeah.
Okay, that would be mostly when you would.
Yes.
That. Okay.
So if I could turn this into a concrete example, I would say, and if there weren't building codes that actually determined how this worked, let's say you were trying to build a ramp for somebody. And you knew that the end of the ramp was going to be 4 feet away from your door. Okay, so that 4 was fixed, but then you weren't quite sure, well, then how high is it going to be, or how long is it going to be? Now we've got ways to be able to calculate how high it's going to be relative to how long, and vice versa. Okay?
Thank you.
No problem at all. Can I do another example where I'm interchanging variables? Yes. Give me just a quick moment. Okay. Let's say we have a circle. There's the radius. I know that the formula for the area of a circle with regards to the radius is simply going to be pi r squared. I know that the circumference with relationship to the radius is going to be 2 pi r. But let's say for a moment I actually have no control over the radius, but for whatever reason I have control over the circumference. If I know that circumference is equal to 2 pi r, but I need to now rearrange this so that I have the circumference with relationship to the radius, because I'm going to need to replace the radius. I don't have any control over the radius. So I'll divide by 2 pi on both sides, and I'll say that c over 2 pi is equal to my radius. That means I can now calculate my area with regards to the circumference, or I'll use a capital C. My area with regards to the circumference is going to be pi times circumference over 2 pi squared. And then we clean that up a little bit. I'm still going to have pi. I will have c squared over 4 pi squared. That pi and one of those pi's disappeared, and I end up with c squared over 4 pi. So now the area of my circle with regards to the circumference looks like that. Does that help, or have I just confused people further? Great. Okay, I have whole bunches of requests for polynomials homework questions. So I'm going to try and take them in numerical order. So far I have requests for 1B, 2E, a couple from question 3, a couple from question 4, a couple from 5, 1 from 6, and a whole bunch from 9. I'm being asked for B and D. Sorry, I'll make sure that I get both of those. So a couple from question 1, and we'll start there. Okay. So this is from polynomials. Just call up the homework. One B says uh, 5x cubed minus 3x squared minus 3x plus 7 minus all of 5x squared minus 4x. I'm going to go on a bit of a slant just to squeeze this under the score, plus 2. Okay. The biggest trick when we're doing this adding and subtracting of polynomials is to watch for when you're subtracting and there's a minus in front of your brackets. That's most often where things go sideways. This minus needs to be distributed. Okay, so this is where, when I say distributed, you want to think of this in a strange sort of way. It's like having a minus 1 outside of this bracket. So this is like saying plus minus 1 times all of those things. So then we end up with 5x cubed minus 3x squared minus 3x plus 7. Negative 1 times 5x squared is minus 5x squared. Negative 1 times negative 4x becomes positive 4x. Negative 1 times positive 2 becomes negative 2. Sorry, and I don't need the bracket out front anymore. I only have the 1 cubed term, so 5x cubed comes down. I have negative 3x squared minus 5x squared. I owe $3. I owe another $5, so I owe $8. Negative 3x, positive 4x. I owe $3, but I have $4, so I'm left with $1. 7 minus 2 gets us 5. Same thing goes for the next example. And again, it's another one with a negative, so we have to watch for that. So I end up with x to the 6th minus x cubed plus x minus 1 all minus 4x squared minus 3x plus 2. This minus is going to share. The first part just comes for the ride for now. Negative times a positive gets me negative. Negative times the negative gets me a positive. Negative times a positive gets me a negative. I only have the 1x to the 6th term. I only have the 1x cubed term. I only have the 1x squared term. But I have an x and a 3x for a total of 4 x's. Negative 1 minus 2 gets me negative 3. All good there? Okay, going back to question 2E, had a request for that one. Question 2E says x minus 1 times x minus 2 times x minus 3. We can't do all of these at once, so you sort of pick a pair and start by multiplying those out. So I'm going to take the first two, I'm going to multiply these. X times x gets me x squared. X times negative 2 is minus 2x. Negative 1 times x is minus 1x. Negative 2 times negative 1, positive 2. X minus 3 comes to the right. I'm going to clean this up so I have fewer terms to work with. X squared minus 3x plus 2. And then x minus 3. So then we go again. X squared times x, x cubed. X squared times negative 3, negative 3x squared. Negative 3x times x is also negative 3x squared. Negative 3x times negative 3 is positive 9x. 2 times x is positive 2x, and 2 times negative 3 is negative 6. Now we look to put together our like terms. I have only the 1x cubed term, so it comes along. Negative 3x squared for negative 6x squared. 9x plus 2x gets me 11x, and then minus 6. So the big trick with these things is, 1, take it in pieces, and 2, simplify as you go. Don't try and multiply this times that. You can simplify in your brackets, so do that first. Then you'll have fewer pieces where things can go wrong. Next, I'm being asked for 3C. X cubed. Where does it come from? I have x squared times x gets me my x cubed, and it just keeps coming. Right, so x squared times x gets me x cubed. 3c. Let's switch up the colors just for a little bit. So 3c is asking me xy. I think it's minus y, or is it plus y? Minus y, all squared. Remembering that when you've got something in brackets and it says squared, it does mean take the whole thing and let it multiply by itself. So this becomes xy minus y times xy minus y. So xy times xy gets me, oops, I don't need the brackets, it's all going to come out just once. There's a couple of ways you can write this. I'm going to write this as x squared y squared. And then xy times negative y is going to be negative x y squared. Negative y times xy is also going to be negative x y squared. Negative y times negative y will be positive y squared. X squared y squared just comes along. Negative xy squared and negative xy squared. It turns out I have two of those. And then the y squared comes along. I think I was also asked for G in this same grouping. Which in this case happens to be root 3 minus root 6 all squared. So this becomes root 3 minus root 6 times root 3 minus root 6. Square root of 3 times the square root of 3 is just 3. Square root of 3 times negative square root 6 is going to be negative root 18. And then we do it again for another negative root 18. Negative root 6 times negative root 6 is going to be plus 6. Cleaning things up, I can put 3 and 6 together. That gets me 9. And then I have two of these, so I can literally say I have two root 18s. Root 18 has a square in it. Just a quick sidebar over here so you can see what I'm doing. Root 18 is the same as saying 3 root 2. And I have two of those, so I end up with 6 root 2. Everybody good so far? Okay, moving on to question number 4. Where we're being asked to simplify the following expressions. There was no specific letter in there, so I'm going to take, I'm going to do question A as the first example, and I'm going to do question D, so you can see how that works. Yeah, so I will do A and D, and hopefully the pattern will be enough in there so that you can see how this all works. So, question 4A, 1 over 2 plus root 5. And of course, with this, we're not allowed to have our square roots on the denominator, no radicals in the denominator. So when we go to simplify this, always take your denominator, change the sign, and that's all you need to do. And then do the multiplication. So when we do that, on top, I'm going to get to minus root 5, no problem. 2 times 2 is 4. My middles cancel out because this is a difference of squares, and then root 5 plus negative root 5 gets me negative 5. So I get 2 minus root 5 on top. I get a negative 1 on the bottom, which we can write like that, or we could simply write as the negative of 2 minus root 5, or you could write it as negative 2 plus root 5. Any of these 3 answers would be taken as correct. I'm going to see if I can squeeze D in underneath here. So D is saying 2 over the root of x plus h minus the root of x. And again, we're going to multiply by the difference of squares version, so I'm going to get x plus h plus root x over square root of x plus h plus square root of x. And this is a multiplication. And when we do that, I'm going to get 2 x plus h's plus 2 x is on top. On the bottom, I'm going to end up with an x plus h minus an x. My top doesn't change. But I have an x minus an x on the bottom, so I'm just left with an h. Is that all clear for people before I move on? Any questions there? Okie doke. Moving on to question 5. I have requests for B and D from question 5. Oh, these are the long division ones. Okay, so we need a little bit of space. I'm going to start off by writing it out in the form that it needs to be. So I'm going to get x plus 2. And this is going to go into x to the power of 4. Give myself a bunch of space. 3x plus 1. Now, the reason I've given myself a bunch of space is because one of the things that's easy to forget that we have to do when we're doing polynomial long division is expressly say what we don't have. Let's take a little bit more room and get this right. So I have 0x cubes. I have 0x squareds. oops, get our signs right, minus 3x plus 1. Okay, now that we've got all of our pieces in, 4x squared plus 0x cubed plus 0x squared minus 3x plus 1, now we can go ahead and do this. Starting from the top, what do I multiply x by to make it into an x to the fourth? I multiply it by x cubed, and I end up with x to the fourth. X cubed times 2 is 2x cubed. We subtract. That goes to 0 by design. 0 minus 2x cubed is negative 2x cubed. We bring down the 0x squared. What do I multiply x by to turn it into a negative 2x cubed? I multiply it by negative 2x squared. Negative 2x squared times 2 is negative 4x squared, and we're subtracting. That goes to 0 by design. 0 minus negative 4x squared gets me to a positive 4x squared. We bring down the minus 3x. What do I multiply x by to turn it into a 4x squared? I multiply it by 4x. 4x times 2 gets me 8x. And we're subtracting. That goes to 0 by design. Negative 3x minus 8x gets me down to negative 11x. And I bring down the 1. What do I multiply x by to make it into an negative 11x? I multiply it by negative 11. Negative 11 times 2 is negative 22. We subtract. That goes to 0. 1 minus negative 22 is positive 23. That becomes our remainder, so we go with plus 23 over x plus 2. Whew. Any questions there? And or can anybody spot any mistakes or errors I made in arithmetic? Pretty sure I got that one right first try. Okay, let's do another one. Let's do 5D. Taking this away in 3, 2, 1. Okay, 5D. Same thing, I'm going to set it up right away. So we go with x squared minus 1. And this is going to go into x cubed minus 2x squared minus x plus 1. Okay, this is going to be slightly interesting because we're dealing with a squared here. We're going to end up skipping around a little bit. Okay, same way to start. What do I multiply x squared by to turn it into an x cubed? I'm just going to multiply it by x. And when I do that, I get an x cubed here. X times negative 1, though, is just minus 1x. And I line that up under the x that I've got. Okay, so we're lining up under things with the same powers. And when we subtract, that's going to go to 0. Interestingly, that's also going to go to 0. Okay? Nobody needs to panic. We just bring down the next thing in line. And when I do that, I end up with 2x squared. And I can also bring down this plus 1. So then, what am I going to multiply x squared by to turn it into negative 2x squared? I multiply it by negative 2. And when I do that, I get a negative 2x squared there. And then negative 2 times negative 1 gets me a positive 2. And we're still subtracting. So that goes to 0 by design. 1 minus 2 gets me a negative 1. So then we can go with a minus 1 over x squared minus 1. And that's what our final answer looks like. So that one's a little funny, just in terms of having to skip spaces. But there's no problem. We can just still go ahead and do that. Is the answer key different? Let me take a peek at the answer key. This is for 5D. Oh, that was clearly me moving too quickly. That should be minus 1, not minus 3. That's just me making a very silly arithmetic error. Yeah, so it should be x minus 2 minus 1 over x squared minus 1. Okay, 6D. Factor out any common factors. Okay. And with 6D, I can see why it looks a little bit funny. So, sorry, not 5D, 6D. 6D says factor out any common factors, and you're being given 6 times, 6A times A plus 1 plus 18 times A plus 1. Now it turns out the very first common factor we can take a look at is this A plus 1. That's the first thing we can pull out. So we go ahead and do that. I'll put that out front. And that just leaves these other two pieces. I have 6A plus 18. Now from here, I can pull 6's out of both 6A and 18. So I'm going to throw that way out front. My A plus 1 still comes for the ride. 6A divided by 6 is just A. 18 divided by 6 is 3. So we end up with 6 times A plus 1 times A plus 3. Another one of those from question 6 can do. So let's start off by looking at the one right above it, where it says 4x squared, 4 times x squared plus 2 and 9 times x squared plus 2. This is a slightly simpler example, but again, these things in brackets tend to be our common term. So that can come out front. And then I end up with 4 plus 9 on their own. Well, 4 plus 9 can actually go together. So I can simply say, that's 13. And those just go like that. Does that help, Allison, or would you like yet another where it's slightly more complicated? One that's more complicated. Okay. I'm going to pull one out of my head. This won't be part of the homework set. Sorry, give me just a quick minute here. Okay, I'm going to do this even slightly more complicated so that you can see where this all comes from. So this all comes from an idea called factoring by grouping. Okay, so let's say that we were left with 12x plus 24 plus 18x plus 36. Out of these first two terms, I can easily pull a 12, so I'm going to do that. And when I do that, I'm left with x plus 2. Out of these second two terms, I can pull out an 18, so I'm going to do that. And that's also going to leave me with x plus 2. This becomes my common term that I can pull out, so I do. And that leaves me with 12 plus 18 in my other bracket. These actually go together, so I go ahead and I do that. And when I add 12 plus 18, I end up with 30. And then that x plus 2 can go like that. One more, just so that all of this is clear. Let me just do this over really quick. Okay, so let's say that we were given 15 ax plus 15 ay plus 3 bx plus 3 by. Same idea. I'm looking for what I can pull out of my first two terms. I'm looking for what I can pull out of my second two terms. Out of the first two terms, I can pull out a 15a. So I do. And it leaves me with x plus y. Out of my second two terms, I can pull out 3b. So I do. And again, it leaves me with x plus y. My x plus y is now what's in common, so it goes out front, leaving me with 15a and 3b. Now, 15 and 3 both divide by 3, so I can pull a 3 out of this set of brackets. And when I do that, I can stick this 3 way out front. X plus y still comes for a ride. 15 divided by 3 leaves me with a 5a. 3b divided by b, or by 3 rather, just leaves me with b. Does that help? Yes, 5a plus b. That's what that says. Why does the 3 go in front instead of going right there? Just by convention. We could put it there, but when you do that, it looks kind of funny. Because I have x plus y times 3 times 5a plus b. So we just tend to throw that number, by convention, we just throw it out front. But you could put it there. It wouldn't be wrong. You could stick it at the end if you wanted to as well. Okay. Anything further on that? Okay, I've got a little bit of time left and a bunch of requests for problems from question number 9, which is probably where I have the most errors in my answer key also, because I was rushing at that point to try and get things done. But let's take a look at question number 9. I'm going to start. I'm going to start with 9b, as I've had certainly multiple requests for that one. So we'll start there. 9b, which says 3 over x squared minus x over x squared minus 1. Now, most of the time when we're doing things like that, when we're dealing with polynomials in fraction form, their first step is to do all the factoring on the bottom to see what's missing. So we're going to do that just to see what we've got. So I end up here with a 3, and my common factor here is x. So I do that, and then I have x minus 1. Here, this is a difference of squares I have in my denominator. So this factors into x plus 1 and x minus 1. So now my x minus 1 is what's in common. So this side needs to multiply by x plus 1, and this side needs to multiply by x. And then I'll have everything the same in my denominator. So this side multiplies by x over x, and this side multiplies by x plus 1 over x plus 1. And when we do that, our denominator stays as x times x minus 1 times x plus 1. No problem there. 3 times x plus 1. So 3 times x is 3x. 3 times 1 is 3. X times x is x squared. And then we can just leave it just like that. Moving on to question C, which is going to take up much more space. So, unfortunately, I'm going to have to get rid of this for a minute, and I'm going to want to... okay, so this is 9C. Oh, let's make sure I'm on the camera here. Which asks us for x squared plus 2x plus 1 all over x squared minus 6x plus 8 divided by x squared minus 3x plus 2 all over x squared minus 4. So again, we have to factor everything. On top, x squared plus 2x minus 1, what multiplies to 1 but adds to 2, that's 1 and 1, so I end up with x plus 1, x plus 1. On the bottom, what multiplies to make positive 8 but adds to make negative 6, and the answers are negative 2 and negative 4. This says divide. In order to divide fractions, we flip that second one and turn it into a multiplication question. So I will turn that divide into a multiply. My bottom, which becomes my top, is a difference of squares. So it's x minus 2, x plus 2. In my denominator, what multiplies to make positive 2 but adds to make negative 3, and the answer there is x minus 2 and x minus 1. From here, we go ahead and we look for anything that's going to cancel and make our lives easier. The first thing that we can spot is I have an x minus 2 over an x minus 2, so those can disappear and we're fine. I have an x minus 2, x plus 2, that doesn't work. X minus 1, x plus 1, that doesn't work either. So we're stuck with what we've got. Fortunately, this is a multiplication question, so we can just go ahead and multiply. Our denominator, we do not need to multiply out. X minus 2, x minus 4, x minus 1. And our top, we could multiply out if we needed to. I don't think we actually have to in this case. I think we can leave it as x plus 1 times x plus 1 times x plus 2. This is the correct answer. This is, I was just remembering, this is one of the ones I discovered has the wrong answer in the answer key. And what happened in the answer key is I think when I was doing my notes, I wrote that down as an x plus 1, so things canceled where they shouldn't have canceled. And I think that I canceled those two, which is not the case. They don't actually cancel, so this is the full and correct answer. Moving on to one of the more complicated ones, I think I'm going to do question E was the next request. Yes. Okay. Same idea. X squared plus x minus 12 all over x squared plus 2x minus 24. And this all multiplies by x plus 6 over x squared plus 8x plus 16. We factor everywhere that we can. What multiplies to make negative 12 but adds to make positive 1? The answers are x plus 4, x minus 3. What multiplies to make negative 24 but adds to make positive 2? The answer there is x plus 6, x minus 4. X plus 6 doesn't factor. It's all on its own up top. On the bottom, what multiplies to make 16, positive 16, but adds to make positive 8? The answers are x plus 4 and x plus 4. From here, we look for all of the places where we can simplify. Well, I have an x plus 4 on the bottom, an x plus 4 on top, and those cancel. I have an x plus 6 on the top, an x plus 6 on the bottom, and those can cancel. Leaving me with an x minus 4, an x plus 4, and an x minus 3. So x minus 3 is on top, x minus 4, x plus 4 is on the bottom. I have time to squeeze in one more, so I'm going to squeeze in 9f, which is another addition one. So again, we're going to be trying to make common denominators. Give everybody just a quick chance to finish here if they need to. Okay. So 9f x plus 3 on top, x squared plus x minus 20 is on our first side. This can be added to 1 over x squared minus 16. Again, we factor x plus 3 on top, what multiplies to make negative 20, but adds to make 1. I have x plus 5, x minus 4. X squared minus 16 is the difference of squares, so it's x plus 4, x minus 4. So, trying to make a common denominator, what's already in common? The x minus 4. What's different? An x plus 4 on one side, and x plus 5 on the other side. So, this side here will multiply by x plus 5. This side over here will multiply by x plus 4. And when we do that, on top, I end up with x plus 3 times x plus 4, which I'll clean up in a little bit, plus x plus 5. On the bottom, we just have x plus 5, x plus 4, x minus 4. Cleaning it up a little bit, x squared plus, or x plus 3 times x plus 4 gets me x squared plus 3x plus 4x gets me 7x in the middle. 3 times 4 is 12 plus x plus 5. And then this all just comes for the ride. Finally, putting together the like terms that we can put together, x goes with 7x, 5 goes with 12. So x squared plus 8x plus 17 all over x plus 5, x plus 4, x minus 4. Okay. We're just about at the end of our time. Is there any questions on anything that I've worked out so far today? Anything else anybody would like clarified before we wrap it up for today? Okay, for those of you who have been following along with me, unfortunately our Winnipeg Jets don't seem to be able to pull it off today. We're presently at Calgary 5, Winnipeg 2 with just about 3 minutes left in the third. So I think that's probably going to do it for today's game. Tune in again on Thursday for the next game where once again we'll have an updated score. If you have any questions on any of this that you didn't want to bring up with the group, feel free to email me. If you have any questions on anything that comes up between now and Thursday, feel free to email me. If you come across, as you're working through your homework questions you'd like me to go over on Thursday, please let me know. Also, as per usual, if you're